Hello friends, I am Professor Swanan Dongre and in this video we are going to study the series and parallel combinations of resistors. So first let us see what is series combination. So as the name indicates, in series combination the resistors are connected in series. Means what? They are connected one after other such that the current flowing through all resistors is same while the voltage or the potential appearing across each resistor is divided. So I can take the example with the help of two resistors. Say you are having two resistors. Say first one is R1, second one is R2, right? And they are connected across the supply, DC supply, say, which is having the total voltage V. So here if you consider the current which is starting from this positive terminal of this supply, it will flow through this R1 as there is no other path for the flow of current. So same current will flow through this R2 and it will complete the path. So that is why here the same current is flowing through both the resistors, hence they are connected in series. So in series combination current is same while the potential will be divided. So how to calculate this potential? You know the basic Ohm's law. In Ohm's law, V is equal to IR. So if you consider the series combination, in series combination the current flowing through the resistors is same. So that is why we can treat it as a constant. Hence what it indicates, in series combination voltage across resistor is directly proportional to its resistance value. And if you calculate that, say V1 is the voltage across R1, V2 is the voltage across R2, then the total voltage V will be equal to V1 plus V2. And what is the value of V1? V1 will be directly proportional to the resistance R1 and it will be given by V1 is equal to R1 divided by total resistance, that is R1 plus R2 multiplied by total potential. So this is nothing but the voltage which is appearing across resistor R1. Similarly, what will be the voltage across R2? It will be R2 divided by R1 plus R2 into total voltage V. So here in series combination there is division of voltage, so that is why it is also act as a voltage divider, that is potential divider. And in series combination there is the resultant resistance of series combination. If you consider this series combination, the resultant resistance of equivalent resistance of series combination, it is equal to R1 plus R2, and here the equivalent resistance is greater than R1 as well as greater than R2. So there is increase in the equivalent resistance. Now if you consider the parallel combination, second, the parallel combination. In parallel combinations, the resistors are connected in parallel, means their ends are connected to each other, so that the current flowing through each resistor will be different, current will be divided, but the potential which is appearing across the two ends of each resistor is same. Now let us take one example. So here if you are having the two resistors which are in parallel, say R1 in parallel with R2, right? So this is R1, this is R2, and the total voltage which is applied between these two resistors is say V, right? Then what will happen? The current which is starting from this positive terminal, it will say it is I. When it reaches to A node, when it reaches to A node at the junction of these two resistors, what will happen? It will be divided into two parts. I1 is the current flowing through R1, I2 is the current flowing through R2. Then they will again combine at B point and here you will get the current total I. So this is parallel combination. The voltage which is appearing between these 2 points A and B, that is voltage across R1 as well as voltage across R2, it is same, and that is nothing but the supply voltage. So here there is division of current. Now if you consider again basic Ohm's law, V is equal to IR, or I is equal to V divided by R. In the parallel combination, voltage appearing between two ends of each resistor, it is same, so that is why it can be treated as constant. Hence, in parallel combination, the current flowing through the resistor is inversely proportional to its resistance value, and it's a bit obvious. If the resistance is small, current will be more, right? In series combination, voltage is directly proportional to the resistance value. Why? Because if the resistance value is increased, the voltage drop across that resistor is increased. Now here in parallel combination, the current flowing through the resistor is inversely proportional to the resistance value. Hence, what it indicates here, the current I1 which is flowing through R1, it will be inversely proportional to the value of R1. And if you want that exact value, what you can do, you can, here I1 is nothing but the current flowing through R1, it will be inversely proportional to R1, right? And it will be directly proportional to R2. So it is R2 divided by total resistance R1 plus R2 multiplied by total current I. So this is the value of current. Now here in parallel combination, the equivalent resistance value 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2. So friends, if you consider now the equivalent resistance value in parallel combination, so it will be R equivalent will be equal to R1 multiplied by R2 divided by R1 plus R2. So here the equivalent resistance value is smaller than that of the each resistor value, that is, it is less than R1 as well as less than R2. You can use this concept. For an example, you are having, see, two resistors. If they are in series, if you are having two resistors having same value, say 1 kilo ohm and 1 kilo ohm, if they are in series, then their equivalent resistance, it is 1k plus 1k, it will be 2k. So that is, it is twice of each resistor. It is twice of each resistors. If you are having n resistors of resistance value R in series, then their equivalent resistance will be the n times R, n times R. Now let us consider the parallel combination. In parallel combination, if, let us consider each resistor is 1 kilo ohm, then if I put this value in this equivalent resistance, 1 kilo ohm multiplied by 1 kilo ohm divided by 1k plus 1k. So 1k plus 1k, 10,000. So 1k multiplied by 1k, that is 10 raised to 3 into 10 raised to 3, that is 10 raised to 6 divided by 2k. So if you solve this, you'll get it is equal to 500 ohm, which is half of the resistance value. So if you connect n resistors of each of resistance value R in parallel, then their equivalent resistance value will be equal to R divided by N. So this concept can be used if you are having, say you are having a short circuit in parallel with any resistance value. Let us consider you are having a short circuit. So this is a resistor of 1 kilo ohm, and in parallel with that you are having short circuit. What is the resistance of short circuit? 0. So that is why equivalent resistance, if you use the formula, that is R1 multiplied by R2 divided by R1 plus R2, it is equal to 1k multiplied by 0 divided by 1k plus 0, so it is equal to 0. So short circuit in parallel with anything, it is always equal to short circuit, means 0 resistance. So that's all about this series and parallel combination. Thank you.